Then we're going to be doing staining, so you use two things. And I brought some of my grids down. I didn't bring any of my forceps because guess how much they cost now?
400.
They're each pair of forceps, like a little pair of forceps like this.
I recently got one.
They're $30 to $40 to $50 per. I looked it up, and you need to know what kind you're going to order if you ever order them. So this is how many there are.
I can't see. How much does it say?
Well, we'll go to that later, but just look at how many different kinds of forceps. 1, 2, 3, 4, 5 times 1, 2, 3. So there's like 20 different kinds.
At least.
If you don't write down the number and the name of the ones you like, then when you leave here and you go get a job and you need a pair of forceps,
you won't know which forceps.
You'll look at this and you go, "Oh, I don't really remember."
But maybe the image can show you. Not very detailed.
You know,
They all look the same in the image.
Oh, I guess.
they all look the same except for these are number 4s where they have this indentation, and these are number 3s where they're like torpedoes or spindles, something like that. That's the only difference. And there's numbers, and there's Dumont, and there's Inox, and they're all made in Switzerland, right? Because that's where they make watches and where they have the best jewelers in the world. But you need to know about forceps, and you also need to know one little thing about grids. There's a shiny side and a dull side. If you don't know what that is, I set some up here. Whoops, I had them set up. So the dull side is on the right and the shiny side is on the left. You should be able to look at those and tell the difference. Because you always, if you're going to coat your grids, you always want to coat the same side. That way you'll come down on the plastic, you know, so you have a film. Otherwise, it might be the plastic, might not. If you got.
However, when you have the form bar on the parafilm, and when you cut it out, as long as you know which side is the parafilm, then the other side will be plastic.
As long if you can keep track of that. But what if you develop a good technique for getting them on the shiny side, and then you know, oh, this is a dull side grid. I'm not going to be able to use this one. Anyway. So you should be comfortable with just looking at these, and you can see that one side is shiny and the other side is only shiny around the rim. Okay, so then these grids are 200 mesh grids. And
What is the
these,
ideal for thin sections? Is it 300 or 100?
You know, I am like Dr. Barlow. I don't coat my grids. I don't use coated grids, so I always use 300 or 400.
So there's no form bar on the grids, and what holds it from going through the grids?
It's big enough.
Somebody cut really nice sections.
Oh, okay, I see.
Right, so they stick, and I clean the grids either with a very dilute solution of nitric acid, very dilute, so that I can see them change color, or I'll soak them in alcoholic KOH, which is a solution that is in the Chem Handbook, page like 1065 or something like that. And,
So the nitric acid?
or you could do alcoholic NaOH.
Is that just to clean the grid?
It's to oxidize the copper. Just gets all the stuff off of any oils or things that might make it hydrophobic, and so
You
they're.
cannot use with alcohol in sonicator. You cannot use alcohol in sonicator to clean the.
Just alcohol?
Yeah.
No.
We did before we do the plastic.
Yeah, but we're also using form bar.
Yeah, but you're coating with a hydrophilic surface, right? It's a foam bar.
Are we free to try that method as well with the nitric acid?
I wouldn't do it in this class. This is what I'm just telling you what I do. That's the way I do it. And then when I use the alcoholic KOH, they have to sit in there in the alcoholic KOH for at least 30 minutes to get clean, to oxidize.
And you've gotten better results
I think
from
they
that?
saponify the fatty acids and make it hydrophilic. So you have to decide which kind of forceps. Oh, and these are just some of the names that I wrote down on the forceps that I use.
And how much were they?
Well, when I bought them, they were only 35. Now they're 44 to 50.
Oh, really? Oh,
Yeah.
It's a lot cheaper than how much I bought.
If you buy them at 10 Pella, that's where I bought them. So you could just look at those. Some are 3, some are 3C. It depends on the brand, and I apparently like all different brands because I found 4 different brands. I mean, they're all Dumont or Inox or something like that, and all from Switzerland.
Do we need to know about these ones for the exams too?
Okay.
I don't think we do.
So
It's not in the presentation. You didn't go over this.
then there's the issue of, okay, I'm going to use these. There's the issue is, what is this? Right? Do you know what that is?
No, it's
You
not.
know.
All the
Okay, so there's 2 ways you can do that, and I really like that, and that is you can. Sorry that I just had to take everything.
iPhone 6? Wow, you're
Pictures.
pretty technologically advanced.
I think that's still the 5.
Oh, really?
Yeah. The 6 is like super thin and round.
Okay,
Oh.
so there's 2 ways of making your locking forceps. You can do it with a paper clip, which is this side, or you can use an O-ring. And you don't always have an O-ring, but you always have paper clips, right?
Mhm.
And you just bend it so that one side looks like that, and then the other side looks like that, just a single bar. So you can make your own locking forceps without an O-ring, because you might have to order the O-ring from McAllister's up in LA. It might take a day to get here, and you may need it right away. And these actually, for me, I like the paper clip. It slides it more easily for me. And then this is a stain. And this is the way I store mine.
This is the urinal?
This is lead
Oh,
citrate.
lead citrate.
And then I also wrap it. I don't know why I do that, but I wrap it in foil. And I do
is
the
it
same
lead
with.
sensitive,
Yeah,
right?
yeah.
I don't
Urinal
know.
acetate itself is
No,
lead
no, but this is
sensitive.
lead citrate.
I'm pretty sure it's also
But-
like.
But
Do
I
you-
wrap it up. I
Do you
just have always
do you
done
stain it
that way.
first with the urinal acetate and then stain it with
Right.
lead?
We'll
So
go
that
into-
will.
I'll show you how to do that.
Oh, this is.
This is just a stain,
Yeah.
right? Okay. So now you know how to lock the sample, and that allows you to come straight down and control your motion. Okay, here's your section. You want it to be parallel. You want the grid bars to be parallel to your section. And it doesn't always work out that way. Sometimes they go here and there, and then when you press down, they scatter everywhere. So it's sometimes it's just like, even if you have ribbons, it doesn't always work great. So what I do, and I have to use magnifying glasses to see because it's just too, the detail is too small. So I just grab these guys on the edge, hopefully, and then I'll lock it. And then before I pick up the sections, and I usually pick them up on the dull side, but so I'll turn this, and I go like that. And then that way I can come in and I can guide my hand, and I can have amazing control over wherever I want. I can use the little
The eyelash.
hair to get it in place, and then I can go either down and just touch it straight down, or I can go up and then drag it at an angle if it's a serial section group.
Bending it like that.
This is just what I do. right?
Okay, but that'll pop off the
Form bar.
form bar, right?
Why don't you use
Most
form bar?
likely.
I don't use form bar.
But it would if you did.
Well,
So what's-
not necessarily, because I do this with serial sections too.
Okay.
I think to kind of go off of that, some of the form bar will a little bit pop off, but there will be still some good sections of the
Okay.
form bar that you can
You
use.
know, and when I do serial sections, I'll either use a bar grid or slot grids and hope that I get it oriented correctly. Because if you get it oriented and even if your section's like this and you're just a little off, by the time you come to the 5th section, it's going to be under the grid bar what you want to see.
And you
So
only do
see
one slice per grid, right? One thin slice when you're picking it up.
I think you can
per
do
grid.
more.
Oh no, I put a lot of slices on there. I try to get it all the way across the grid. You know, just even if it's whether it's serials or individuals, I just, and you may wind up with overlapping. You know, one section on top of the other. Or something. You just, and then okay, so now you've got your sections on your grid, and this is going into picking sections up, and I don't know whether Dr. Barlow's going to show you. He's pretty good at the sectioning stuff. They can move around, you know, just because there's so much surface tension from the water, and the forces are, you just don't think of them as being strong, but surface tension forces on the water edge really are strong, and they can move your sections from, you know, hey, I came down straight, everything was perfect, and then when I lifted it up, it was no longer perfect, but you've got water on there. So then the question is, how do you get rid of that? And one of the ways that you can do it is you can take a piece of filter paper like this and wet the filter paper, and then you don't have such a you know, going from dry to wet. You have, it's already wet a little bit, and so the water tends to go more gently off of the grid. And I don't know whether he'll show you about that. And so one of the things that I think you should do before you do your staining is practice. And so what I did was I set up a little, this is 100 microliters. You should set this up like this with water and take a grid and see how comfortable it is for you to take the grid and place it on top of.
But that's a more difficult one because it's a smaller area.
Well, you can put it, I mean, you can, this is just showing you what 100 microliters looks like. So you may want a bigger droplet, but it's always, because you're using parafilm, it's always going to be hydrophobic on the bottom, so it's always going to be curved to some extent. Yeah, the droplet. It's not going to be, you know, uniformly spread out, and so it's not going to be so easy to get your grid on there. That's why I think you should practice till you feel good about it, because it's okay. So you can take this and you can unlock it, and then you can just go down on top of your droplet, and you can drop it off.
That's the top.
But you have to be able to do that, right? Without destroying what you have. And so, yeah, that's assuming that I'm coming down on top of the section. I've dried it. Sometimes I'll let it dry in the forceps because I worry about moving of the sections if I were to touch it to a piece of wet filter paper or even to a piece of dry filter paper. So these are just, you know, some of the things that you want to be thinking about that you're going to go through when you go from making beautiful sections and spreading them out, and now you're ready to pick them up, and you go, oh my God, I don't have anything. What's going on here? You can actually, if you were to take and you have your sections on this, you can actually turn them over and see them without any magnification. You can almost inevitably, you can see where your sections are on the grid. And you could decide, okay, is this worth staining? And then as you cut each grid, make a little note in your notebook, good sections, nice gold sections, you know, describe for yourself the kind of sample you have. Don't think that you're gonna, you know, 2 days later that you're gonna be able to remember all that information. It's just not gonna happen. So you should have like maybe a separate page in your lab notebook that allows you to, okay, number 7, you know, C7, that is great sections. Be very careful with that one, you know. Number 8, thicker sections, not as important, but you know what you have cut, and that way you'll be able to get more leverage from it.
So this is similar to the negative staining, basically. It's what we do with the T4 sample, the washing and the staining.
Yeah, I guess I do it differently with negative staining too. What I do with negative staining, as long as we're talking about that, I will pick up my grid and I will, whoops, yeah, so that's why.
So this is your own method for the negative staining, right?
Yeah. Okay, so, and I'll lock it in place, and I'll add the stain droplet and then wash it off, and then droplet it again, and maybe 2 or 3 droplets, and you'd have to do it into the urinal acetate waste, right? But you've got urinal acetate, you're putting your droplet on, then you're putting another one on. Maybe.
So you're not worried about washing down the sample when you're doing that?
No, because the sample is going to adhere or not adhere, and then I'll come in with a little triangular. Oops, what's going on? These are not my forceps.
Oh.
They are, but
the Wattman paper and
Mine,
wick off the excess?
mine actually lock and stay in place. And then I'll just take a little piece of filter paper that I mean, this is negative staining, right? I'll just,
Oh, you don't like to rip it off with the rough edge?
no, I don't like that. This is the way I do it, right? I don't use any books. I'm sort of self-taught.
Wow, that's impressive.
So, yeah.
But it works for you. And that's
going to places like UCLA and UCI, self-taught, watching other people who are
Yeah.
skilled. And so then I'll just take it and I'll just touch it like that. And it'll drain. It'll be like a little, I don't know, lens or something like that, you know, curve. And then when that's dried down, you can actually watch the stain spread over there. So it doesn't ball up, and then you have a good, you know, better control over it for negative staining, I think. Okay, so you're staining it now. The usual, and this is not gadolinium. Gadolinium is up in there. I'll get that down in a minute. We'll do the real thing. The usual amount of time that you want to stain, and I think that handout said you
10
can.
minutes.
You can put this over it, which I think is a good idea to keep all, you know, aerial junk out of it. It doesn't hurt. And we usually use the larger part of the petri dish on the bottom flat. That would be like the top, and then this goes on top of that. So it sits for 10 minutes, and then you're gonna pick it up. These to make sure that it doesn't fall out, because I do want to show you how I do this. So you're going to get some, make sure that this is water, not alcohol, right? Because it's really easy for stuff to, because this one
Surface tension would be different for alcohol, right? As opposed to water.
Right. It would. Okay, so now you've got this, and so normally what I would do, and I'm not going to put all the water in there, I think I'm just going to do it, I just run it down the side of the, like that.
Oh, that's a big one.
And then I'll spray both sides. And then you've got to, so now you got your sections on here, you know which side they're on, and there's water on both sides of the grid. So what I would do in this case, and if it's urinal acetate, I'll put the initial wash into here, right into the waste jar.
Right.
So you don't want to go from
Really dry. Yeah, so you're wetting it.
So this is the way I do this. I just take it and I look at, okay, my sections are on that side, and I'll just go like that.
So which side is the side that has your sample on it? That's the top side?
Well, he did the dull side, right?
Sections are up.
Okay, the sections are up.
Okay.
Up. So sections are up, and I just drop it off that way. And then you don't want to go into the lead citrate with any liquid, because there could be CO2 dissolved in there, and then that'll give you deposits of lead carbonate. And so you want to make sure that your sections are completely dry, no liquids at all. So what you want to do at that point is you want to just take it and move it to a nice dry area, and just let it sit until you're comfortable that it has dried.
Oh, you let it dry?
How long
Yeah,
does that
you-
normally take?
I usually kind of hang out for about 5 minutes.
Okay.
Okay.
You know, and
So
I may be doing 5 or 6 grids or 7 grids at a time. So I'll have drop, and then so I'll start one, and then I'll kind of, for timing it, I'll do a timer, you know, and I'll kind of keep, and I might write down, okay, grid number 1 I started, and then this one I started 2 minutes later. I always allow 1 minute so that I have enough time to pick it up and put it onto a piece of paper. So I never do 1 grid at a time. It's always a lot, because you can't, your sections they're never going to be all good. And so you want a lot of choices. You know, you want to have at least 5
And
different
you play
grades.
the numbers game and just have a lot of numbers.
Yeah,
in case
because you're not going to get everything perfect. I mean, it's just the way it is. The staining might not be good. It might be good urinal staining, bad, or in this
So
case.
it's almost like luck, right? increases your chances for
It
luck.
is.
Like,
It
anymore.
is because even in your sections, there'll be areas that where staining is good, and then other areas there might be some precipitate or something of that sort. And so we're using an unknown because none of us have. Well, I don't know. Dr. Barlow now has, but I've never used gadolinium. That's in the lanthanum series. So lanthanum is a heavy metal stain that is common to electron microscopy. It's very scattering of electrons, and I guess that's why they chose gadolinium. But I don't even. I mean, I can't really quite picture in my mind where it is on the periodic table, but I'm sure it's there somewhere. Okay, so
Towards the bottom somewhere.
okay, so now you've done your
You're drawing.
gadolinium, but we just use water. So now we're going to do it for real, so you can see the safety considerations, how they factor in, right?
Do I need to dim the lights?
Although there's no sections on here, these are just grids, right? So, and then one other thing is, okay, how do you get rid of, like, let's say that this is your uranium droplet, right? Your waste. So it's a waste. So you're gonna take something like this, and you're gonna soak it up.
With gloves, right? And then dispose of it in the box right there.
Yeah, and gadolinium isn't
Radioactive.
radioactive, so it's not going to go in here. And I'm not sure where the solid gadolinium waste would go. I don't work in this lab, but in any case, this is where the liquid gadolinium goes. So the other way you could do it is.
What about that jar right there? Is it
The
that,
yellow
No, that's
cap?
lead.
What
That's
about the yellow cap?
the hazard waste?
this one. This is liquid. Right?
Yeah.
So what you could do is,
We can't throw that in there?
this is just water.
Oh, I mean, if it were gadolinium, I mean.
Not in radioactive. This is radioactive waste.
I think in the video that's
Much more cautious.
Gadolinium radioactive.
Is that what Dr. Barlow said? No,
that's what I thought. It was the one adjacent to
I
the
put it in
station.
there.
Yeah.
Wait for negative staining, that's what I did.
Yeah.
Okay.
Please, we're all gonna die.
I mean,
Yeah,
there's
but for
nothing else.
negative staining, that's uranium.
No,
You-
use
you-
gadolinium.
Oh, you use gadolinium.
Gadolinium
for
and
negative
uranium
Yeah.
acetate.
Oh, okay. All right.
That's why this method looks very similar to
Okay.
the negative.
Yeah. All right. So the other thing you could do is you could take this, and this is just water. So you could take and get your 100. Let's put it here like that. So let's say that's your 100 microliter drop. So then you can go like this and soak most of it up because these are hydrophobic, right? They're not going to retain water. And then you'd go in, take this off, and then. But I'm not going to. This is just distilled water, so I'm not going to put that in.
Oh, for your gadolinium, right?
Yeah, just put your liquid gadolinium in there because it's clear like water, so it would be, conceptually the same thing. Okay, so now what about, when we're using real gadolinium? So this I'm gonna just,
You just throw this in.
yeah, I'm just gonna put this in. Okay. And we like it to be inside of a dish because that way, in case something happens, it's contained. And we also, when we're using the real thing, because of what happened with Part E, I'm suggesting that we, from now on.
But she was already wearing
and-
like glasses
I think
when
I
she
didn't
got.
have glasses. Once.
Right. No, I know that, but
So this on top of the.
see, like this is the way I would do it. This is the way I work in a lab when I'm working with urinal acetate or glutaraldehyde or something like that. Under the hood, if you have the sash pulled all the way down, but if you're out on the bench, this is the way that I do it. Okay, so this is just like from start to finish with not water, but with stain. Okay, so one of the things you want to make sure of when you are working with chemicals that are, potentially a biosafety issue, I always like to seal that down so that it's not curved. Because if it's curved, if the parafilm is curved, it's going to slide the droplet off, and then you're going to go, oh, so why didn't I fix that up the right way? Okay, and so the other thing is, I like that I thought I had fixed these, but this still sticks, and so it's going to have to probably be taken apart more. This is just water. But see, it sticks right here. It's because
of the epoxy? Someone
no,
added epoxy?
I don't know. Something is not. It's bent or something like that, and so it's just not. It's not smooth. It really
some of them
needs,
don't even have that actually. I guess.
yeah, but that's a one. It's a 1 mil. So okay, so it's nice when you're working with things like this. It's nice to be able to not use your hands and just discharge it. So it's good to get a good kind of an issue with it. Okay, so now we're gonna.
So we don't need gloves.
This is when you would use gloves when you're using the real stain. And so, there's gloves over there. When you're using toxic heavy metals, you do want gloves. Uranium or anything like that, lead, you want gloves.
I guess if your techniques are like pristine, like Dr. Misako.
These are small. I don't know if they're going to fit me. Are there any other sizes, do you know?
There's large right there if you like.
This one?
Yep.
Oh. Okay, so this is the last pair. All right.
Do you want me to get more gloves? Do you know where they are?
I don't know where they are. They're probably over there somewhere by the hood. But I don't know. Or in a cabinet.
We'll ask when we switch groups.
You want to make sure to let Dr. Parler know.
Yeah.
Yeah. Or I'll figure out what it is. Okay, so now you've got your.
Oh, that's the waist, I think.
Yeah, that's
the
the
Oh.
waist.
Here you go,
You
Dr.
don't want to use
Misako.
that.
Yeah.
I don't want to touch that. Should we turn off the lights? Is the light sensitive?
Turn the lights off.
Turn them down.
I think for this small amount of period of time,
Oh,
it's okay. As
yeah,
long as you don't leave it.
I never do that.
Oh.
No.
I mean, there's this whole risk of working with
bother with
the
that.
lights off. It might not be.
That's not on my program.
Wait, so
I'll live with, a little bit less.
Dr. Misako, so when you're emptying the pipette, you would empty it here, right? Not the yellow one.
I would empty it in here. This is the waste collection. And
What is
then,
the yellow
and then
one for?
ultimately you'd use,
Oh, so it's the
a
same
funnel.
one.
This is, I believe
We have
this
two.
particular funnel is
That's
for
good.
lead. But
Is there one for?
we should have one for gadolinium. Because I don't think we would want to just pour it in there.
Probably not.
Okay, so I'm going to use like 50 microliters. Half the amount, more or less. Okay, and so these you're saying you just put into there?
Yeah.
And that's the value of, so you don't have to pull it off, you just discharge it into there.
Right, if it has the.
Okay, and then you're going to close this up before you proceed further. And
Do you wanna put
it's
that
not
back?
radioactive,
Oh, yeah, we can put it back in the jar if you want.
and so
That works too.
and you just pick this up. And so the sections are up, and then I'm just going to drop it on there. And then you're good. And you wait 10 minutes. Through the magic of television.
Would you like to put the gadolinium back? If you're done with it, so it's not being exposed to light further.
I don't know if I should touch that.
Well, presumably there's none on the outside.
Right,
I mean,
presumably.
yeah, right. Can you trust anybody nowadays? Okay. And so now we're working with the real thing, and so we've waited our 1, 2, 3, 4 minutes, 5, 6, 7, 8, 9 minutes, 9.5, 10 minutes. Okay.
That's fast.
So it's stained for 10 minutes. So now what do you
TV
do?
magic.
Like what happens when you're
Why
having
do you put
fun?
the top part on it?
The what?
Why Why we cover it?
So that in case a fly comes along or a
Or even dust,
particle
you know,
of
maybe it's
dust
some
or something like
accidentally
that.
see.
Our
You
section
You know,
is-
once I worked with a guy who was
Well, if you want to do other grids, then you might get dust on that. If you leave it open, then the dust gets on the gadolinium, and then you put your grid on top of the dust.
it's just for
Just
su-
a safety.
microscopy is like
when things go wrong. It's like, well, it
super
definitely wasn't
cleanliness. You know, you want to be so picky that people hate you. You know, really, if they don't hate you, you're doing something wrong.
that. So make them do.
Okay, so now we've waited our 10 minutes, and we've got the water wash here.
So if we want to do it like a wash for the negative staining, like we put like droplets and we just dip them.
Well,
in it, can we do that?
there's you can do it a number of different ways. So that is another way of doing it. So I'm going to go in with a fresh. So I'm just going to go in here and borrow some liquid. So this is another way of doing it. So you can take your gadolinium stain, it's done now, or urinal, you can do the same thing as long as it's a urinal water.
Because I'm scared to do the washes you did, to lose everything.
And then you can go like this, wash it 3 or 4 or 5 or 6 times, and then you can lock it. And then this is the way that I like to do it. So what I would do at the beginning, because I know that there's stain on there now, so I would put just like a little droplet of water on that, and then
Scared to drop or dropping.
and you hope that you don't drop it in there. And it did drop in there, unfortunately. So that sometimes does happen. Like if you don't lock it correctly, the stain can drop in there. You just have to be aware that that kind of thing can happen.
That's a risk taker, man.
Okay, and so then you're gonna do 2 cleanings. You're gonna do one where you can just take the gadolinium and put it into the gadolinium waste. And the other one with the water part, I'm just gonna soak this up. Put that in there, and then cut another one off. Because this is just a minimal amount of gadolinium on this. And then for this one, I'm going to take the pure gadolinium and then collect all of it, and then just, this one could actually go in here. And then this would be, I think you would consider this to be your waste. When you're finished staining with it, and I'll put that in there.
By the way, Dr. Bizzacco, is there a percentage? It should be 2 to 5% gadolinium. We don't need to dilute. Is it already?
I think that hopefully that is ready to go.
So
I
that's already
believe
the
it is.
I
Dr.
mean, there
Barlow
should
said it
be
was.
no reason why, you wouldn't put a stock solution in with other staining solutions, right? That's not a common way of doing things. You would, like with a stock solution or something like that, let's assume that it's light sensitive, I would ordinarily wrap it in foil, like uranium, I wrap it in foil, I keep it in the refrigerator, and then I have a label on the outside of it, and a label on the inside.
So these are just the aliquots that we're in.
And then these jars, the uranium that's up in here, each one of them is labeled, but they're not covered with foil, so I'm assuming that aqueous urinal acetate isn't really that light sensitive because people are opening and
Maybe
closing.
because it gets used up more often.
Yeah, and there's a lot of people like Jennifer or Jen comes in, and Adriana and people from Bernstein's lab and the Rower lab and so on. coming in here. Okay, so now I'm gonna try to go in here and see what's going on with that grid. There's another grid in there too. There's actually 4 grids in there. So I'm gonna just
the
leave
only
it.
one using that method, so those are probably.
Obviously, somebody else has had the same issue. All right, so we'll just leave it since I'm not alone. All right, so we have to continue with the lead stain. So anyway, so let's say.
So we'll pretend that it's stained with gas.
Right. So this is stained with gadolinium, and then you get this like a little wet.
And why do you do that?
I just for more authentic. You know, to be more authentic.
Like just because it just got washed, it just
Well,
went through.
water, so it's washed, right?
Uh-huh.
And so I want to just drop it off, and as soon as it hits the water flows. But on the dry paper, it doesn't flow, and if it did, it would go boom, and it would put a lot of stress on the sections.
That's
And
like
so
a vacuum, right? It's
well, it's because it's going from dry to wet, and it just drags all that water down. As soon as the surface tension is broken, it goes down, and it can move your sections, and so that's what you want to avoid. Okay, so then at that point, after it drags it down a little bit, you then want to move it to a dry area. And then let it dry for maybe 3 to 4 minutes, 5 minutes, something like that. You don't need to let it. I mean, if you have something to do for 10 minutes, that's fine. But if you don't and you just want to wait, you could wait 4 to 5 minutes. Okay, so then you want to go to the lead. We're going to close this. You really want to leave this open so that it can evaporate down and so that it can have the least volume. And then you're going to take this off, and then you're going to set up your lead citrate stain. And Dr. Barlow said, I don't need to tell you how to make lead citrate because he would rather do it himself. So I will tell you in a thumbnail way. So you get the correct amount of lead nitrate, and you get a 50 ml beaker. You take the lead, you boil some water gently for 10 minutes so that you get rid of all the carbon dioxide that would be in the water. It's gently boiling, it will remove all of it. And then you mix the lead citrate and lead nitrate along with some water, not a lot, but I forget, it's like a few mils of water. And then you
Both lead citrate and lead nitrate.
and then you'll get a precipitate of lead citrate. And you shake it and shake it and shake it to get lots of CO2 dissolved in there, and then you get basically lead citrate is formed between the two, but you're shaking it and shaking it, and then you add up to 50 mils of water in a volumetric, and then you're adding some, I forget exactly how much of it is, but it's very, very concentrated sodium hydroxide, and then that will clarify everything. So you've got your lead citrate formed, and then the high pH dissolves it, and so that's what allows for the stain to take place.
So there is no lead nitrate. It's a lead citrate.
There's what?
Lead nitrate is a lead.
Lead nitrate plus sodium. I think it's a sodium citrate. Yeah, it's a salt. And so you get lead citrate.
chemical reaction.
Okay, so now we got the cap off, and you reach in. Oh, and then the reason that you don't want to store your lead citrate in glass is because it's alkaline. It's very alkaline. It's like pH 12, and it will dissolve the glass. Just like you don't store your pH electrode at pH 7, you store it at pH 4,
Right.
so that it doesn't dissolve. Right? Same principle. Glass dissolves
Isn't that
at neutral to alkaline pH.
Oh,
Okay, so
Oh, you mean the waste container?
yeah.
I'm guessing that
First
it
waste,
has
right?
the carbon dioxide in the air mixes in with it, so it dissolves out, so it kind of negates the.
so you want
That's my
to
theory
take
anyways.
and get rid of a drop or so in here. I'm just going to do 1 drop. And then I'm going to put just a little bit on here. Just a couple of drops. But you want, because there could be carbonates in that because it's closest to the exit point. So you want to put it in the waste. And then you're going to put this back in here. And they're inside of here are pellets of sodium or potassium hydroxide that will soak up all of the CO2 that's in the jar. And so, unfortunately, plastic is permeable, so the CO2 can actually diffuse through there. So you need to keep some sort of hydroxide, either sodium hydroxide or potassium hydroxide, in there. Now,
On the handout sheet, it says to put some grains next to the.
you don't need to do that.
Okay.
Nobody does that. That was a long
Why
time
would you
ago.
do that, or why did they?
The reason would be that if during that 4-minute staining period, there would be CO2 that would dissolve into the stain, causing precipitates, which would deposit on your sections.
Okay.
But 4 minutes, nothing's going to happen. It's just
Okay.
it's not.
Just long-term storage.
Yeah,
rather than
it's just not going to happen.
Got it.
Okay, so then you're going to take, because now it's all dried, and before you want to make sure that there's no water on these guys, and that doesn't make a problem for you to pick up your grid. And I'm not going to lock this because I'm just going to take it and put it right on there. Okay, and so now you're going to cover this. So if you were to use it, if you do get picky and you want to be perfect, you can do that and you would put them a couple in there, or one across from the other, or right next to it,
Where are they?
but not on the.
He didn't do them. They're in the big.
Yeah,
top
we just
jar.
don't do that anymore. We used to, I never did it, but some people did it. 4 minutes is so fast time, it's not going to have time to dissolve in there and cause problems. So then you let it sit. I stain for 4 minutes. Some people stain 5 minutes. I don't think you want to stain any longer, because then you do run that risk or possibility of having lead carbonates form and cause deposits or altering your sections in some way or another.
Handout says 10 minutes.
What?
In the handout, it says 10 minutes.
It says in the handouts, yes, I
Yeah.
know, I read it. I didn't like it.
It's too much.
Okay, so let's assume that your staining is done. So this is the way that I do it. Just go in. And in this case, I'm a little bit on the picky side. So this is where I get picky and my true nature comes out. So I'm going to do 100 microliters of water here, and I'm going to keep it far away from the lead because I don't want these two to mix. And the other thing is, when I do this, I use boiled water. So I'll put boiled water down like that. This is okay.
How we doing, Rick?
Almost done.
Okay.
And then I'll pick this up and I'll wash it here, and then I'll wash it here again, and then and I'll lock it. And I just go like that, and then I will spray the sections directly. And then now I'm all done. All the lead is gone, and I'm ready to go. And I'll just drop it off like that.
So you drop it in another wet spot again too?
Mhm.
Okay.
And then I will take it and move it. Once I've dried it off, I'll take it and move it to a dry area so that it can dry. And then I will take the lead itself. I'm just put this right in there, although you can put it into here if you like, and then I'll take this and wash it out, because these have a little bit of lead in it, but not very much. And then I'm not sure where does your lead waste go in here too? No,
I haven't used it.
no, I don't think so.
Does it say in the box, is there a label on what things go in there?
No, it just says dry waste. U N A C. I'm not sure where the
Yeah, I think it'd be pretty safe to just put it.
I think everything from like here over goes
Okay.
in there for dry waste.
And so then this also I would put into dry waste, even though it's probably not contaminated to any extent. I still would put it into dry waste. And then this is done. And this is your grid, and then you just want to close up. But crack it, leave it cracked so it can evaporate, but close it and leave it cracked. And the same for this, you want to leave it cracked. Probably this one, since there's a fair amount of liquid in there, I might leave this one open almost all the way. And then these are just regular trash because they haven't been, and I don't know where this goes in glass dispo. No, this isn't waste, this is just dispo pipettes.
I would still put the tips
Yeah,
there.
I would still put it in there just in case there's some contamination.
No, because there wasn't. I just took water.
I mean, if there were though.
Yeah.
But if it's just water.
It's just water, so I don't
Well,
know.
then you can just put it in a regular pipette bucket.
Okay. Yeah, this is just water, and then this is just trash.
Oh, we just dropped it. I don't know if that one is radioactive or no. No, this one.
No, this is paraffin.
Oh, okay.
Okay, and so that's it. So do you guys have any questions about it?